Hey everyone, so I'm looking at 63 in class graphs from charts. And 22 shows the following. There's this x sub 1 and x sub 2 and x sub 3. And what we're told here, oh, and there's a second line. So this is going to be y prime, and this is going to be y double prime. So what do I see? I see the same points. Yes? Yes. This is y prime is greater than 0, so I'm going to put a plus. I'm going to put plus, and I'm going to put a minus over here. I know that y prime equals 0 here, and nothing here, but y prime equals 0 here. Okay, plus plus, yes, y prime equals 0. Good, and then y double prime equals 0 here, 0 here, and this says y double prime is negative here, y double prime is positive here, and y double prime is negative here. All right, so let's see what we know. We know that y is increasing and concave down. We know that y is increasing and concave up, which is why even though y prime is 0 here, yeah, I have a horizontal tangent, but I don't have a min or a max. There's no sign change on y prime. Instead, I have this inflection point. See the change in signs in y double prime? That means that this x sub 1 is an inflection point. Okay? And remember, we're making graphs that are continuous when we do this. So what happens next? Well, f is increasing and concave up until I get to x sub 2. X sub 2 is here. After which point I see that y prime is positive, so I'm still increasing, but now I'm going to be concave down. So there was an inflection point, and increasing and concave down until I get to x sub 3. And after x sub 3, y prime is negative, so y is decreasing and concave down, and so I have that. So there's my graph for 22. Okay? All right. So will you please now go and do problem 23? Go to 23, come back when you're done. We know that y prime is negative everywhere. X sub 1, x sub 2, x sub 3, but not just at those points, just everywhere. Y prime is less than 0, so y prime is negative. On y double prime, I'm looking at plus, minus, plus, minus. Okay, so y prime, y double prime. I know that because y prime is negative everywhere, y is always decreasing. First, y is decreasing concave up, then y is decreasing concave down, then y is decreasing concave up, then y is decreasing concave down. So y is decreasing concave up, y is decreasing concave down, y is decreasing concave up, y is decreasing concave down. There's x sub 3, that's x sub 2, and there's x sub 1. Okay, that's 23. How about 24? Well, you do 24, right? Do 24. 24 says we've got x sub 1, x sub 2. We know that y prime is positive, is positive, is positive. And we know that y double prime is negative, positive, negative. So increasing and concave down, increasing and concave up, and increasing and concave down. That's x sub 2, that's x sub 1. I like it. 25. Ooh, undefined. Remember, while y prime is undefined, it doesn't mean that y is undefined. Our function is supposed to be continuous. So when y prime is undefined here in problem 25, what that tells me is I have a vertical slope. Okay? So 25. Goink. We've got x sub 1, we've got x sub 2, we've got y prime is positive, y prime is negative, y prime equals 0, y prime is positive. Okay? And here y prime is undefined. On y double prime, what do we know? We know that y double prime is positive, and then y double prime is positive and positive. Y double prime is everywhere positive, and here y double prime is undefined because y prime was undefined. If this point is undefined, I'm trying to take the slope at that point. That's still going to be undefined. So I see this function is always concave up. First, concave up and increasing, then decreasing and concave up, and finally increasing and concave up. So there's x sub 2, this is x sub 1. Hey, you want to know why y prime was undefined? Because the limit of the slopes from both sides were not equal to each other. There's 25. Do we have a zero slope at x sub 2? Yes, we have a zero slope at x sub 2. 26. 26 says y prime is 2 until we get to x sub 1, and y prime is 2 here, and then after this point, y prime is positive. Y double prime is equal to 0 over here and is positive over here. So this is what I think is happening. I have a constant slope. When I have a constant slope, that means my function is linear. This is a positive slope, a slope of 2, so I'm increasing until I get to x sub 1. After x sub 1, I'm still increasing. I'm still increasing, and I'm concave up. Wow. Now, see this? The slope at x sub 1 is 2. In order for the slope to be 2 at x sub 1, that means the slope on this side has to be 2, but it also means the slope on the other side has to be 2. And so it's still going to look like a parabola over there. But at that point, the slope on this side, the limit as x approaches x sub 1 from the positive side of y prime, is got to equal 2 also. The slope over here has to be approaching 2, and the slope here is approaching 2. That's what I understand from that. Okay? Y prime is positive? Sure, look at all that increasing. Here, y prime has a constant slope. I'm sorry, y has a constant slope of 2, therefore y prime is 2. Because y prime is 2, the derivative of 2 is 0, so I don't have any concave up or concave down on this interval. No, that's not concave up, nor is it concave down. Okay, and then our last one here, 27, we're given y prime, x sub 1, x sub 2, and y double prime here with the same points. That's definitely x sub 2. This is undefined. This is positive. This is negative. Up here we have positive, negative, positive. And I've got an undefined here and a 0 here. Okay, remember, this isn't a vertical asymptote because sometimes the derivative is undefined because the function doesn't exist there. This is instead a pointy point. And I know that because I'm told in the stem of these problems that I have to make a continuous function. And anything with a vertical asymptote is not continuous. So I'm looking for y to be increasing and concave down. And then after x sub 1, I'm going to be decreasing and concave down. So there's x sub 1, decreasing and concave down. until I get to x sub 2. And after x sub 2, I'm increasing, and I'll give up. Increasing, and I'll give up. All right. I like that better over here. And see, look, can you take the derivative at that point? The limit of the slopes from this side is definitely a very negative number. But the limit of the slopes from this side is approaching 0. So negative number does not equal 0. No slope possible there, which is why this is undefined. Do I see a slope of 0 at x sub 1? Sure, there's a slope of 0 at x sub 1. Okay. No, I'm not going to do 28. You could do 28 if you want. I think that's an exciting problem. Very few people get 28, but if you're looking for a challenge, go do 28. All right, have a great day, everyone.